Okay, we are in Algebra 2. It is Monday, April 13th. Guys, hope you had a great Easter weekend. Good news, this is the last day of the current really long unit that we've been on, dealing with rational equations, rational expressions, rational functions. In other words, the functions, the equations, the expressions we've simplified and work with have had fractions all over the place. And our last topic of this unit, but yet all skills you need heading into next year, is called complex fractions. Okay, we'll wrap up this unit with our last topic today. Today, I'm asking you ahead of time, please pay attention to what I'm saying. Focus on the explanation and the steps. Stay with me and try to understand it. It's not a race. We don't need to fly through it. We're only doing 3 problems, but it is important you listen and understand step by step. So for your notes today, again, April 13th, 2020, Monday, that's the date. The title of today's topic or notes, complex fractions. All that means when it says complex fractions, as you look at this first problem, is I've got a problem above the division bar that looks like a simplification of fractions problem that we've done. And below the fraction bar, there's a second problem that also is the subtraction of 2 fractions. So since it's fractions over top of fractions, they call these complex fractions, and our job is to simplify each expression. Huge piece of advice. Listen to this. Find the big, large fraction bar that's in your problem and just pretend the top is its own little problem and pretend that the bottom is its own little problem. So we're going to simplify the top, then go down and simplify the bottom, and then we'd end up dividing 2 fractions and can use our rule for division of fractions at that point. All right? So for now, here we go. This x obviously is understood to be over 1. And I am subtracting 2 fractions, right? It says x over 1 minus 2x over y. Oh, well, if I'm subtracting 2 fractions, we've been saying the entire chapter when simplifying that if you're ever subtracting or adding 2 fractions, you got to get a common denominator, don't you? So if this second fraction has a y on bottom, the first fraction is going to need to have a y on the bottom. So I multiply him by y over y. So do you agree that this first denominator is going to be a y? The second denominator is also a y. So basically, I can take those 2 fractions, since they now have the same denominator, and I can combine them together into one fraction, whose common denominator, of course, is just the letter y. And up top, obviously here we had x dot connected to a y, giving us xy minus, and then that 2x that's still up there for the second numerator. Okay? So we combine that into one fraction. Now we're going to go underneath our fraction bar. And when you look there, this guy's also understood to be over 1. And once again, we need to get a common denominator, don't we? So if this denominator here is an x, we need this denominator here to end up being an x. So don't make this complicated. We're going to multiply that by x over x. Agreed? So this denominator will be an x minus, and then this fraction has a denominator of x. So I can combine them together into one fraction whose common denominator is x. And up top, since we had x times y, we've got xy minus, of course, the letter y. Okay, so far so good. Now, if you will remember, when we divided fractions, what's the rule when you divide fractions? Leave the top or the first fraction alone, change division to multiplication, and flip the second fraction over. So guys, bottom line is I'm going to leave this first fraction alone, xy minus 2x over y. I left him alone. Agreed? And this, since I'm dividing by another fraction, I'm going to change division to multiplication. And I'm going to take the bottom fraction and I'm going to flip it over. I'm going to reciprocate it. So if I flip it over, it would be x over xy minus y. Okay? And because these are now dot connected, I can just times all that together and make one fraction for my final answer. So when I go to write my final answer here, now notice we were taught when we multiplied rational expressions, if you can factor each individual term, go ahead and do it. So if you notice this first numerator right here, do you agree that they have an x in common? So I can factor out an x, right? He's got an x and he also has an x. So I'm going to factor out an x, leaving me with what? Y minus 2. Now notice that's dot connected to another x. Well, if I have an x out front that I just factored out and I'm going to times that by another x, certainly that makes that x squared. Agreed? Down below, I've got a y times, oh, now look at this group right here. You notice that they have a y in common. So I can factor out a y. So if I factor out a y from that group and times it by the y that was already there, that's going to be y squared, leaving me with what? Well, if you took a y out of there, do you agree if I take away a y and factor it to the front, it leaves me with x minus 1, correct? Because there's understood to be a 1 in front of that y. So bottom line is you kind of cleaned up your answer at the end by factoring, if possible, creating the final answer that I've circled. Okay? Let's try another one. Don't panic, it's not that bad. Number 2 says 1 minus 2 over 3x all over x minus 4 over 9x. Let's do the same thing. I have a large fraction bar here. Let's just look up top and treat that as if it was its own little problem. Watch how easy. This one is understood to be over 1. I want to get a common denominator, so I'm going to multiply this guy by 3x over 3x. Does everybody agree that this denominator 3x now matches that denominator of 3x? So I can combine them into one fraction. My common denominator is 3x. And what's in my numerator? Well, if I take 3x times 1, that's 3x minus this other number 2. Down below the large fraction bar, this guy's understood to be over 1. I want to create a common denominator here, so I'm going to multiply this first fraction by 9x over 9x. So when I combine these together and get one fraction, my common denominator is obviously 9x. And up top, careful, I've got 9x times x, so that's what, 9x squared. Then minus, of course, that other number, 4. Okay, what step are we on now? I've got a fraction bar. Since I have a fraction being divided by a fraction, I'm going to leave the top fraction alone. So leaving him alone, I got 3x minus 2 over 3x. Change division to multiplication, right? I changed division to multiplication, and the bottom fraction gets flipped over, right? So when I flip it over, I've got 9x over, now careful. Notice this 9x squared minus 4, since this is getting flipped over, is going to end up on the bottom, correct? Well, before I even write it, I hope that you notice, guys, isn't that the difference of two perfect squares? That can be factored, right? It says 9x squared minus 4. Let's factor that into, okay, for 9x squared, we'd have 3x times 3x. I have a minus at the end. My signs are different. And for 4, I'd use 2 and 2. Whoa, so this dot connected situation has a lot of stuff that'll cancel. Agree that I can cross out the 3x minus 2's. I can cross out the x's. And even this 3 on bottom and that 9 on top. Don't 3 and 9 cross cancel. The 3 is gone, the 9 becomes a 3. So when the dust settles here and I go to write my final simplified answer, the only thing remaining up top is a 3, and the only thing left on the bottom is 3x plus 2. And I did it. Okay? Finally, the last problem of this long chapter on rational expressions and fractions, equations, etc. Number 3 here. It's not as bad as it looks. Stay with me. My fraction bar, everybody notice, is right here in the middle. Agreed? So let's go up top and treat the top as if it was its own little problem. I'm adding two fractions that don't have the same denominator. So, do you agree this first fraction I'm going to multiply by the other denominator of x plus 2 over x plus 2. And the second fraction I'm going to multiply by the first denominator of x minus 5 over x minus 5. So, when I now add everything together, I'm going to have one fraction whose common denominator, of course, has both of those things, an x plus 2 and an x minus 5. Big deal. Now up top, this 4, since it's being multiplied by x plus 2, is going to get distributed, giving me 4x plus 8, plus, then I distribute this 2 and get 2x minus 10. So guys, bottom line is when I combine like terms up top there, do you agree 4x and 2x gives me 6x, plus 8 and minus 10 gives me minus 2, all over x plus 2 and x minus 5. So if I treat the top as if it was its own little problem, we would end up with that. Agreed? Now, focus down to the bottom. Let's go under the big fraction bar and treat that as if it was its own little problem. Well, it's pretty obvious if I'm adding these two fractions together, I need to take this denominator and factor it because it's a trinomial, isn't it? If I factor him into two binomials, I've got x and x. Minus at the end means my signs are different. And I would use what? Plus 2 and minus 5. So agree that that's been changed into those two binomials. So when you compare that to the other denominator, the other denominator needs to be multiplied by what? X plus 2, agreed? X plus 2 over x plus 2. So this fraction, guess what? When I add all that together, has a common denominator also of x plus 2 and x minus 5. Up top, I've got this 2x that's just sitting there, plus, when I distribute the 3, 3x plus 6. There's the big fraction bar. When I add all these like terms together, right? I have a big fraction bar in the middle. When I add these like terms together, I've got 5x plus 6 over that denominator consisting of x plus 2 and x minus 5. Great news. Anytime you've got a fraction divided by another fraction and the bottoms are identical and match, they cancel each other out. So lo and behold, the final answer is simply what's left there on your paper. 6x minus 2 over 5x plus 6. And we're done. Okay? If, for some reason, any of those three don't make complete sense to you, you're a little shaky, guess what? You're allowed to go back on the video and watch the explanation of the problem again. You can relearn it by rewatching it and focusing on each step, okay? All right, homework. Again, today is 4/13/20, Monday the 13th. Homework or the assignment for today is a 3-question quiz Let's see if you understand what I just taught you. These 3 problems, of course, are due tomorrow at noon. So today is Monday the 13th. You're hopefully watching this video lesson like you're supposed to on Monday the 13th. And either get busy and work on this now and send it to me when you're finished, or at the very latest by noon tomorrow on Tuesday the 14th, okay? Here's your 3 problems. Hit pause so you can see all 3 of them and copy them down. X plus 3x over y, all over y minus 2y over x. Number 2 is 1 minus 3 over 4x, all over x minus 5 over 11x. And the third one, 2x over x squared minus 9 plus 5 over x plus 3, all over 4 over x plus 3 plus 2 over x minus 3. And remember, guys, all I'm doing for these videos is I'm recording it on my phone, uploading it to YouTube, and then uploading from YouTube to Schoology. So if you ever have issues with your Schoology or your screen or watching from there, you can always go to YouTube, search my name, and all these videos should be there, and maybe it'd be easier to view in that mode. It's up to you. Okay? Great job. We'll see you tomorrow.